Okay. So Husk Power Systems, basically, Husk is a rural utility company. We work with rural energy microgrids. We are currently in operation in India and Africa. In India, we are working in UP and Bihar. And in Africa, we started in Tanzania. And then now we are also aggressively promoting, growing in Nigeria. So we have roughly 10 plants in Nigeria already. In India, we have close to 120 plants in India in operation. What does Husk do? So basically, Husk is a mini grid operator, as I mentioned. We design, build, and operate mini grids using 100% renewable power. Our major focus, and that is one of the USPs that Husk has, is we manage the lowest levelized cost of energy. And that is why we have a sustainable and a growing business in rural markets in India and Africa. Our aim is to solve the energy access problem reliably and affordably uh, all over the globe. We are the lowest capex provider with the kind of systems that we are able to manage. Uh, I'll go into the detail on that. So this is what the rural utility model for Husk is. Basically, the plant consists of a biomass gasification plant and a solar power farm. So in daytimes, the basically this electricity is supplied with solar, and in evening times it is supplied through biomass gasification. And then the battery, there is a small storage system which acts as a backup for midnight and late night usage. Since the late night usages are low, we are able to keep our storage solutions to bare minimum. Most of our generation happens from solar and biomass gasification. As I mentioned, it's a proprietary technology in terms of the complete design. Even from biomass gasification, we have done a lot of innovation towards filtration designs. I'll show a couple of slides. Basically, we deal with biomass gasification in the range of 20 to 50 kilowatt systems, which is very complicated because at these kind of this scale, you don't have the luxury of introducing a lot of capex for filtration and treating the gases. That's where a lot of innovation has happened at our end. And we are actually able to maintain a very low cost of energy with biomass gasification. Uh, we use rice husk as a fuel dominantly in India. In Africa, we have tried maize cobs, rice husk. We have actually tried multiple other feedstocks. Rice husk, since it is easily available in village locations, our cost of transportations are much lower for rice husk. That's why we focus on rice husk as of now. Our grids are three-phase AC powered grids compatible with government grids. Basically, Husk has its own distribution system, which supplies power to each and every household and commercial units with own metering system. So basically, Husk handles the generation, the management of distribution of power, and as well as monitoring and a collection of revenue from the customers. So we are completely in working in parallel to the government grid and are solving the 24/7 reliable access to energy problems in India and Africa. This is a small picture, a simple picture of what a gasification system looks like for us. So basically, if you can see, there's a biomass gasifier. This is roughly a 40 kVA gasifier and has filtration units for cleaning the gas. This is where it ends up finally into a 40 kVA. We are currently using a Cummins engine for powering the electricity. We have also tried multiple other engines. This is one of the engines that we actually have had a good result with and are currently using. One of the major, anyhow, I'll speak about this in future slides, but one of the major innovation in design that we have been able to achieve is handling tar. So I think most of you, if you have dealt with biomass gasification, the major challenge is tar, which ends up choking the engines, resulting in a lot of operation and maintenance cost. And that's where the scale of the levelized cost of energy rises. We have been able to successfully solve this. This is a real example picture of a site. where in our old design, we had such kind of tar issues within 200 hours of operation. And in the new design, if you see, it has been, we tested it with 1000 hours of operation. There's no tar deposition. Whatever tar was being generated, it's just low, basically it's lightweight tars, which actually become a source of fuel in the engine. Uh, what is our system design? Basically, we use a downdraft gasifier. Uh, First, it allows for low tar generation. We have our own proprietary dry gas cooling, so we do not contaminate any water. We do not use any kind of water-based cooling systems. It's a completely dry. We do not use any additional uh, items that we need to purchase except a fine cloth filter, which is for removing any fine particles. Rest, all the filtration systems do not use any purchased components for operation and maintenance. Uh, we have very low OPEX on gas cleaning, as I mentioned, because we do not use any additional material. We have a very clearly defined and managed and trackable preventive maintenance schedule, which is also predictable. So we know when our engines are going to fail or need, sorry, not fail, but when they need maintenance. We know when each filtration system will need maintenance, when the gassy. So everything is properly defined and tracked. Today, currently, we are doing it, most of it manually. But there is a process that we have already been working with, where we have actually tested the complete gasification unit in an automated fashion. So we have been able to successfully operate a 25 kVA biomass gasification unit, fully automatic. I'll not say fully automatic, because the feeding of the raw material and the clearing of the ash, that is still a manual process. But rest of the complete process, which requires skill set, has been completely automated, and we have been operating this unit for more than 400 hours now. We have also been able to synchronize power very reliably. So earlier, if people have dealt with biomass gasification for electricity production, there's a lot of fluctuation because the gas quality keeps on varying. There's a lot of fluctuation because of the quality of raw material. We have been actually able to manage that completely with, first of all, automation, and second, our integration of electricity energy between solar, biomass, and battery. We have a proprietary design where we have been able to solve this, and the quality of power that we deliver to our users is at par with, much better than government grid. So our frequency fluctuations are less than 0.5 hertz. Our voltage fluctuations are less than 5%. Opportunities, why we focus on biomass gasification and have been very focused on improving gasification as an opportunity. First, the fuel is available locally. Second, it generates employment, definitely. Third, 100% renewable. That's how we have been able to manage our renewable portfolio. Fourth, very low levelized cost of energy. So if you compare any other additional source that we use, for example, diesel, which was a use case in most of the villages until Husk came down in those villages. So finally, we are able to reduce the cost of biomass-based energy generation by half in compared to any diesel or any other fossil fuel sources. High level of autonomy, so we can operate it whenever we want, based on our choice. We don't have to depend on anything, because if the fuel is available, it takes less than 30 minutes for a plant to start from scratch, and if the plant is already in operation, it takes less than 10 minutes for the plant to start generating electricity. Low storage requirements, as I mentioned, because we have this generation source as an evening source, we do not need a lot of battery based storage, and as a result, we have been able to successfully reduce our costs. Thank you. I just wanted to keep it short and sweet. One thing that we believe, and I believe personally, is waste is just a mindset. Everything else is just a chemical composition. Thank you.